Welcome all to the chapter 1 application of matrices and determinants. This is M. Satish Kumar. Today we will see example 1.9. Verify AB whole inverse equal to B inverse into A inverse with A equal to 0 minus 3 1 4 and B equal to minus 2 minus 3 0 1. In this question they asked us to prove that AB whole inverse equal to B inverse into A inverse, and they given the value of matrix A matrix and then B matrix. So first we will calculate the value which is present in the left hand side, that is AB equal to, you know the matrix, right, A matrix into B matrix. So we have to multiply the matrix A and B. So how do we multiply the matrix A and B? So we know that, right, to multiply any given matrix you should apply the L-shaped rule, right. So you have to multiply the first row with the first column, right. So in this case we have to multiply 0 with minus 2, minus 0, and then minus 3 with 0, you will get minus 0. Similarly for second column you have to multiply with the first column. 0 with minus 3 you will get 0, and minus 3 with minus 1 you will get plus 3. Similarly, if you multiply the first row with this first column and then second column, you will get these two values. So if you simplify these values, you will get 0, 3, minus 2, minus 7. So next we have to calculate the value of inverse, right? As we know that if we know the value of a matrix AB, if you want to take inverse, the formula is 1 by determinant of that matrix, that is AB, into adjoint of AB. So let's consider this is equation 1. So in these equations we don't know the value of a determinant of AB and the adjoint of AB. You have to calculate these two values first. So first let me calculate the determinant of AB, right. So we already calculated the value of AB, so we have to take a determinant. So how to solve the determinant for a 2 by 2 matrix? You can apply the cross multiplication rule, that is 0 into minus 7 you will get 0, and then minus 2 into 3 you will get plus 6. So totally you will get 6. So similarly for finding the adjoint of AB, you know the formula, right, for 2 by 2 matrix. So M11 minus M12 minus M21 M22. This is a minus. This is representing the minus of a given matrix. And then finally, you have to take a transpose in order to calculate the value of adjoint of A. So how do you find the minor of each and every elements present in the matrix? So you have to eliminate the respective rows and columns, right? If you eliminate the for finding M11, if you have to eliminate the first column and then first row. What is the remaining element? Remaining element is minus 7. Similarly for second element, if you eliminate the second column and first row, you will get minus 2, right? In formula you have one minus, so you will get plus 2. And then for third element, you have to eliminate, the first column and then second row, you will get 3. In formula you have one minus, so you will get minus 3. For fourth element, if you eliminate second column and then second row, you will get 0. So this is your minus, right? You have to find. In order to calculate the value of adjoint of AB, you have to take a transpose. So how do you take a transpose? You have to exchange the columns into rows. So I am writing first row, first columns into first row. Similarly, second column into second rows. So this is your adjoint of AB. So till now we have calculated the value of determinant of AB and then adjoint of AB. If you substitute these two values in equation 1, you can easily calculate the value of AB whole inverse, that is 1 by 6. 6 is your determinant of AB, right? 6 is your determinant of AB into adjoint of AB. Adjoint of AB is this matrix, minus 3 minus 7 minus 3 2 0. So let's consider this is equation 2. Till now we have calculated the value of AB whole inverse, that is our right and left hand side we have calculated. So now next step is to calculate the elements which is present in the right hand side, that is B inverse and then A inverse. How do you calculate the value? So as we know that for taking inverse of any matrix, so the rule is 1 by determinant of that corresponding matrix into adjoint of that matrix. So if you consider this is equation 3, so you have to calculate the value of determinant of B and then adjoint of B. How do you calculate the determinant of B? So B value you already know, right? B is equal to -2 -3 0 1. You have to calculate the determinant for this matrix. So in order to simplify these values, you have to apply the cross multiplication rule. That is -2 into -1, you will get 2, and then minus of 0 into -3, you will get 0. So what is the value? 2. And then for finding the adjoint of B, so adjoint of B, as we calculated adjoint of AB, the same formula you are going to use here also. So M11 minus M12 minus M21 M22, and then finally you have to take a transpose. So for calculating the M11, you have to eliminate the first row and then first column. First column and then first row. What is the remaining element? Remaining element is -1. That is your minor of M11. And then how do you calculate the minor of M12? Simply eliminating the second column and then first row, you will get 0. In formula you have minus, that's for 0, that is not a problem. You have to give 0. And then for third element, you have to eliminate the first column and then second row, you will get -3. In formula you have 1 minus, so you will get +3. And then for fourth element, if you eliminate the second column and then second row, you will get -2. So this is your minor value, right? This is not your adjoint of B. So you have to take a transpose. So how do you take a transpose? You have to interchange the rows and columns. So I am interchanging first column into my first row, and then second column into my second row. So this is your adjoint of B. So we calculated the value of determinant of B and then adjoint of B. If you substitute these two values in equation 3, you will get B inverse. B inverse equal to 1 by 2, that is determinant of B into adjoint of B. So this matrix -1 3 0 -2. So let's consider this is equation 4. So next you have to find the value of A inverse. So same formula, right? For finding the inverse of any matrix, for finding an inverse of any matrix, you have to calculate the determinant and then adjoint. So first calculate the determinant. Determinant of A equal to matrix value of A is given in the question. So you have to apply the determinant. So how do you simplify this determinant? You have to calculate the value by applying the cross multiplication rule. That is 0 into 4 is 0, and then minus of 1 into -3 will get +3. So totally will get 3. And then for finding the adjoint of A, the same formula as we used for finding the adjoint of B. So you have to find the minus of each and every elements present in the matrix. How do you find the minus? Simply eliminating the respective rows and then columns. So if you eliminate the first columns and first row, you will get 4. For second elements, that is M12, if you eliminate the second column and then first row, you will get 1. In formula you have 1 minus, so you will get -1. And then for third element, if you eliminate first column and then second row, you will get -3. In formula you have 1 minus, so you will get +3. For fourth element, you have to eliminate second column and then second row, you will get 0. So this is the minor value, right? You have to take a transpose in order to find the value of adjoint of A. So how do you take a transpose? Simply rearranging the columns into rows. So first column I am writing as first row, and then second column I am writing as second row. This is my adjoint of A. If you substitute determinant of A and then adjoint of A values in equation 5, you will get A inverse. So A inverse equal to 1 by 3, that is determinant of A into adjoint of A, that is 4 3 -1 0. So this is equation 6. So next we have to multiply the B inverse and then A inverse. We calculated the value, right? B inverse equal to 1 by 2 into -1 3 0 -2. Similarly, A inverse value also we have calculated already. So you have to multiply these two equations. So in multiplications, you can multiply the elements which is present outside first. So if I multiply 1 by 2 with my 1 by 3, what is the value I will get? So I will get 1 by 6. So 2 into 3 is 6. And then next multiply the matrix. So how do you multiply the matrix? simply applying the L-shaped rule. That is, you have to multiply the first row with first column and then first row with second column. So first I will multiply the first row with first columns. What is the value I will get? Minus 1 into 4 is minus 4, and then 3 into minus 1 minus 3. Similarly for second elements, you have to multiply the first row with second column. What is the value I will get? Minus 1 into 3 is minus 3, and 3 into 0 is 0. Similarly, if you multiply the second row with first column and then second row with second column, you will get these two values. So if you simplify these values, you will get, finally you will get 1 by 6 into minus 7 minus 3 2 0. So let's consider this is equation 7. If you see your left hand side, that is equation 2, 1 by 6 minus 7 minus 3 2 0, and then your equation 7, that is your right hand side, both are equal, right? Both are equal. So equation 7 and 2 are equal. Therefore, AB whole inverse equal to B inverse into A inverse. So we proved that both are equal. This is your final answer. Thank you guys.